few minutes just to make sure you're in the right spot. This is Onshape and MecSoft, so just hold tight and we will be starting and let a few more people join. All right, I think my computer shows right on time, so probably a good time to get started. Let's see. I want to make sure everyone, before I go full screen with my presentation, I just want to make sure everyone's hearing me okay. So if you could go into the GoToMeeting control panel and just raise your hand, that will let me know that at least somebody sees me. There we go. Perfect. All right. So let me bring this whole thing up. All right, so hopefully you're in the right spot, but if you're into cutting parts and want to see how you can cut some parts with Onshape and MecSoft, this should be the place to go. And just so you know, we're going to be recording this, and this will be there on YouTube if you want to watch this later. So this is something you can share with your colleagues, or if you have to go in the middle of the presentation, don't feel like you can't see everything. However, the whole point, I think, of doing these live events is that this is an opportunity to ask questions, to get answers. You can type in the controls for GoToMeeting, type in your questions. I'm going to be doing a little bit of the presentation, but then we're going to turn it over to Uday and Joe, and they will be able to show you things, and I can field the questions, and that's really where the value comes in here, I think, to a large extent. So I just want to make some introductions very quickly so you know who you're talking to. I'm Joe Dunn. I am a employee of Onshape, and I've been in the CAD industry for quite a long time, and started off with a CAD system a long time ago, but I was with SolidWorks for around 20 years or so, and then I left SolidWorks to start Onshape. So that's my background. Joe, I'll let you introduce yourself.
Right. I'm Joe Anand. I'm the president of MecSoft Corporation. I got a little bit more years than Joe Dunn here in the CAD/CAM industry. Started out in GE Calma in San Diego. I don't know if any of you remember or even know about GE Calma.
I didn't know that.
First. You didn't know that, huh?
No.
So it was one of the first 3D CAD/CAM systems, a company that actually built a 3D CAD/CAM system. They were then sold to Computer Vision, and then I moved on to Intergraph. And then before I started MecSoft. I was at Unigraphics, which is now part of the Siemens PLM division. I have a MS in mechanical engineering from Clemson University, and my focus and passion has always been in CAM. So that's me.
Uday?
Hello, everyone. My name is Uday Honalagire. I've been with MecSoft since 2005. I hold a master's degree in industrial engineering from Arizona State University. I started out as an application engineer. I've been in the role of a technical support manager here at MecSoft Corporation. So I have an experience of about 15 years in the CAD/CAM industry.
Excellent. All right, guys. Just so everyone knows, what we're going to do is we're going to just do a very quick presentation and overview of Onshape for those of you who may not know much about Onshape. We'll find out in a minute. But mainly we want to focus on the CAM side of things and how to cut parts. So it's one thing. And so we'll actually do a demonstration, and Uday and I will work together a little bit. And like I said, at the end of the presentation, we will field questions if we haven't answered everything during our session. Okay. Now, Alex, why don't you put up a couple of the slides? We have a couple of slides that really helps us on how to present today. One slide would be whether or not you've used one of our products. There should be a third answer there. So just pick the one that you've, I suppose, used more. And we can close that one, Alex, because I think that one's going to be a little bit tough because we don't have a both. And you want to show those results too? Sorry, I don't mean to. Oh, all right. All right. So we have. Do you already own another CAD system? And give you guys a few minutes to vote on that one too. We're just going to use all these questions. I think we got about 3 questions because it'll help us gauge who's in the audience right now and what to describe and how much detail to get into.
That was actually a CAM system, the question.
The previous one?
No, the one that you put up right now.
Yeah. Oh, what did I say?
You said CAD.
Oh, sorry. It's what I meant, not what I said. That's what I tell my wife all the time. All right. So 50-50 of people who do or don't have CAM systems. Okay, cool. And then as you can see, we're trying to gauge, I think, where CAM and the cloud come in. And obviously, if you're looking at Onshape, you know that we're a cloud-based product. So it's another important factor for our discussions here, I think. I won't bias anybody here. So, middle of the road. Okay. So we're kind of spread out over there. All right. So why don't I get going on just a little bit of background. So Alex, I'm going to assume that it's our typical on the Onshape MecSoft stuff. So what we can do is what I want to do is I'm going to assume everyone has a little bit of knowledge of Onshape. And so what I don't want to do is get into a lot of detail of it on Onshape. And the reason for that is we do lots of webinars, and either you're using it already, but there's lots of places to go, and we do similar events like this that are dedicated just to Onshape itself. So, but I think that, for a review anyway, let's talk a little bit about what we've done. I mean, basically our company is very much rooted in SolidWorks, if it's not clear. My background was from SolidWorks, and most of us, we were the original team, almost literally, that started SolidWorks at the beginning. And we just decided, after 20 years or so, that the market had changed, technology has changed, the business model has changed, and it was time to start from scratch. So Onshape really is us taking a fresh look and saying, let's see if we can make engineers' lives better, designers' lives better. And a couple of them are just, if you've tried it, you'll notice that it's extremely easy to get Onshape. It's extremely easy to use Onshape. There's no barrier. You just go, you put an email address in, and you're starting to use it right away. It's It runs on every platform, right? We have a system that we didn't want to, we thought this is why we had to start from scratch. We architected this. I mean, this product is architected in a very different way than any product on the market. And one of the clear indications of that is the fact that you can run it on any hardware platform that you have, and it's really refreshing to be able to do that. And it's very powerful as well. The core of our product is similar to any MCAD, mechanical CAD system. It's parts, assemblies, and drawings, right? It's the same thing that you use SolidWorks or ProEngineer or CATIA or Inventor or Solid Edge, or I could name 10 different, or at least a handful of professional CAD products, and that's what we're going after. Onshape is parts, assemblies, and drawings, right? It's a core product for professionals to use, but I think it also means we also work in a very similar way to most of the professional CAD systems out there, because in fact, all of them, to be honest, they're all more common than they are different, and that means they're parametric feature-based modelers. We use some underlying technology such as Parasolid and D-Cube. Those are some tools that we're using under the hood. That gives us that puts us that raises the caliber of our product and puts us in the realm of professionals. And the reason why I say it is probably every product that you have on your desk or that you drive or that you use somewhere is using that same technology. It's pretty much the standard out there of all production use in CAD. Now, what I want to point out or make it clear is a lot of people will look at Onshape, and Onshape is a brand new product. And so we do a lot, and we do a lot already. But there's also some things that probably are missing that you might look at. It's possible anyway. Some people have a complete solution, but I get a lot of questions of, will you do sheet metal, or will you be able to do surfacing, or will you be able to handle large assemblies? And actually, we do large assemblies pretty well now. But the point is that the answer is yes. All right. If you look at Pro-E or Creo, or if you look at SolidWorks, or if you look at CATIA, if you look at those products and if they can do something today, the answer is that you will be able to do the same thing in Onshape. I mean, that's basically a roadmap, because we're going after high-end pro-grade capabilities. It's just a matter of when. I mean, we're on a very extremely aggressive path. Every 3 weeks, our product is updated. If you've been using Onshape, you'll notice that it's constantly getting new functionality. This is not a product where you wait a year and then go through some upgrade process. It's always up to date, and it's always almost literally has new functionality that's allowing us to deliver to you in a very rapid way. And I mentioned this already, but we do run on everything. So it's Windows, it's Mac. I think we'll probably, between the three of us today, we're going to be on Windows and Macintosh, but I could have been on Chrome or even the tablets, everything. It's the idea. It's kind of the whole circle. It's kind of the old school coming back again for those of us that have been around a while, Joe. It's mainframe terminals when you really look at it in some ways, but the thing is that terminals are super smart and cool now, because your tablets or your PCs or Macs are really good terminals, but it is kind of the way I look at the cloud solutions, if you will. Now, what is radically different, most of our users today are using Onshape, and the way they use it is probably, if you're using it today, my guess is you're using it like you use SolidWorks, right? You create parts, you create assemblies, you might create some documentation and a drawing, but you're using it like a standard CAD system, and that's fine, and it works great that way. But what I want to show and what I want to really mention is that it's the hard part for us was not the CAD side. We have most of us have built 2 or more CAD systems already, and we have a lot of experience doing that. The hard part was this, because what we really are is we are a database system. We are a data management system with CAD built on top of it. And it's transparent. There's nothing new for you to do, except for there are no files. You don't deal with files. I love to go into an Apple store. I tell the story in all these webinars, but when I'm in a new city, I'll go to any Apple store, and I'll log in on all my computers, or all the computers in the store. I try to make sure they're not watching me, but I keep logging into Onshape and all of them. Nothing to install. I start running Onshape, and I load my models up right there, and everything's with me. If I had apps, my apps come with me too, but I get the entire store loaded up with Onshape. So, but the database and the data management, what what really is happening, or the difference here, is that you're able to work with multiple people together. The three of us could all be in the same document at the same time, and we don't worry about accidentally overwriting each other's data, and we don't worry about who had the latest copy, or there's the process of checking out and checking in. All that stuff is just unnecessary, and there's a lot to it. But my point is, I would say that that's where you really should take a look at where a very significant difference in Onshape, and it's just about being able to work with other people. All right, and if it's not clear about the business model, this was another reason why we really started from scratch, is that we really had to do this to be able to do this. I doubt any of the existing businesses out there, the CAD companies that are selling very expensive products, can really do this. And it's about the point here is we have a free version and there's a professional version, and there is no difference in CAD functionality when it comes to parts assemblies and drawings, surfacing, large assembly design. All the capability that we ship for Onshape is available to all users, and you can use for free the entire product. What you have to pay for, what we differentiate between free and professional, is privacy. And the idea is that if you use Onshape in a public manner, kind of think of it like Facebook or YouTube or something, but the point is you can build your models and work with Onshape, but other people could see what you're doing potentially. You don't have any limitations at all. But if you have intellectual property that you do want to protect and you do want to save, then you would be a professional user. And that's the way we've decided to attack this, because it allows the education market, allows makers, it allows hobbyists. They've got a tool they can use. Privacy is not a concern for them, and it's a great access point for them. But professionals obviously probably don't want their information, their intellectual property, to be shared. So I really do love this business model, because I think it's just super easy to understand and to get access to. So that was Onshape. Well, I want to turn it over. I think, Joe, you're going to do this part of it?
Yeah.
All right. I'm done.
Okay, so yeah, thanks for the introduction there. We're MecSoft. We actually work very well with the Onshape product. We are very impressed with what Onshape has done with the product, and is really a revolutionary product from our perspective. And so that's why we want to be their partners, and we work very closely with them. And Uday will be later on showing you how our products work with their products. But those of you who are not familiar with us, with MecSoft, let me give you a very brief introduction before we jump into the actual demo. What is MecSoft? Yeah, we are a company that produces Windows-based Windows desktop CAM software products for manufacturing parts in a wide variety of industries. We've been in business for quite a while. Our tagline is, "We are your CAM partner." What we mean by that is CAM is a little bit different from CAD, where you're actually interfacing with a machine tool. And typically there's a lot of issues when you have, handshake going on between the software system and your hardware. And so that's what we mean by being your CAM partner. So we are there. We just don't sell you a product and, go away. We actually stand behind our products, and we are there to support whatever post-processing or any hardware issues that you might have in interfacing our software with your CNC machine. So if you can go to the next slide, please. A little bit about MecSoft. We're a California corporation. Yep, we pay taxes to the California welfare state here. Established in 1997. So we've been around for a while. We have presence in all major world markets, which means, in Europe, in Oceania, in Japan, all the manufacturing markets, we have a presence. Our product is currently translated in over 6 major languages. Next slide, please, Joe. Yeah, as far as our products, we have our Visual CAD, which is a desktop free CAD modeler. Obviously, this is not a modeler that you're going to be using we don't compete with SolidWorks or anybody like that. It's really for the machinist. When you're on the shop floor and you want to bring in models and create cutter paths, and if you don't want to spend money on an expensive CAD system, an additional CAD system, so you probably might have a mainframe or a mainline CAD system like Onshape or SolidWorks or any of the Autodesk, name it. But if you just want multiple seats of your machining software, that's where Visual CAD comes in, where you can load your parts that you've designed in these CAD systems, and then use the other plugins that we have to actually machine it, create cutter paths. We also have a free mill product. It's a completely free milling product running inside Visual CAD. This is for hobbyists and students who want to take a look at CAM, or just getting into CAM and want to get an idea of what CAM does. They want to interface with machines, so it completely allows you to do all of that, including toolpath simulation, toolpath generation, simulation, and post-processing, which are the three basic steps in CAM programming. And then our Visual CAM product, which is our mainline or our flagship product, and it's a full-function CNC programming product. And then we've recently introduced a Visual 3D Print product, which again runs on top of Visual CAD. It's a mesh modeling and 3D print product. Allows you to take bad meshes and fix them up, and create supports and things of that nature, and then send them out to a 3D printer, either using the Windows drivers or the XML language, printer languages, or also G-code. If you have a printer that takes G-code, we can generate G-code as well. And then lately, we've introduced this visual import for Onshape, which is the product, one of the products that Uday is going to be demonstrating. That basically is a bridge product that allows you to take models that you've designed in the Onshape product and bring it into our Windows desktop product. So Joe, next slide, please. And as far as our product modules, we have the milling module, which is again our flagship module. That's really our focus, because that's, if you look at the CNC industry, milling is probably the largest manufacturing technology out there. And we offer our technology from all the way from 2.5 axis all the way up to 5 axis continuous CNC milling. And then we also have a turning product. It's a 2-axis CNC turning product that also is a separately licensed module that you can buy. We also do parts nesting, both rectangular and true shape nesting. Rectangular is typically used in cabinet making and in industries like that. We also offer true shape nesting. And the interesting thing is you can take the nested parts and bring it into machining. So you can do cabinet machining. And anytime you're doing many parts and you want to optimize the location, you want to use this parts nesting product that we offer. And then we also have the 3D printing product I just mentioned, geometry preparation for 3D printing, fixing up bad meshes, holes in meshes, creating supports, and then taking them out to the 3D printer. And we also have an artistic modeling product. This is typically used by woodworkers, and we're doing relief modeling and things like that. So you can take bitmap geometry or bitmap pictures, BMP, JPEG, and PNG files, and convert them to actual 3D geometry that you can use in our machining product. So that's a little bit about our product modules. As far as the industries that we target and we are very strong in, and this is a list of industries. You can go to our website actually to see a lot of these case studies that we have done with various different customers in these industries. Production machining, this is really not in the order of importance, it's just something I've thrown together here. Production machining, which basically means that you're doing a lot of, maybe a single part and you're machining a lot of these. So that means you're optimizing the tool paths. So time is of essence. So you're creating very efficient tool paths, and typically the parts are prismatic parts. Woodworking is a strong industry for us. Furniture making, artistic, both artistic and very functional, as well as artistic furniture. Mold and die making. We don't play that much in the die industry. That is, if we're looking at the automotive dies, we don't play that much. But in the mold industry, the plastic injection mold, yeah, we have a strong presence as well. Aerospace, space, and automotive. These are for, again, the smaller parts for aerospace and automotive. Because of our 5-axis offering, we can do aerospace type of parts as well. Thin rib parts and twisted parts and things like that. And interestingly enough, we also are very strong in music. I mean, this is for musical, instrument makers, things like, guitars, violins, and ukuleles, and any of that, name it, and we can actually machine these parts. And a lot of the music instrument makers are going to CNC these days. So, jewelry and artistic machining, prototyping is big. Also, prototyping, a lot of that is now being done in 3D printing. But there's a lot of materials that you still need CNC. For instance, if you want to do, stone machining or rock or different types of zirconium machining, different types of materials that, for dental applications, you really can 3D print, and that's where the CNC part comes in. And also, we're very strong in education. One of our strengths of our product is our ease of use, and also the various support videos and support collateral that we have developed over the years. And so that's really made us be a strong player in the educational market, because students can pick up the product very quickly. And not only students, that means even commercial applications for our product, people can pick it up very quickly. So that's also one of our strengths. All right, Joe, next slide, please. Okay, a little bit about our pricing. Obviously, I mentioned that we go from, in our milling product, we go from the 2-axis all the way up to 5-axis milling. Not everybody needs 5-axis. So what we have done is we kind of configured our product to tailor it to different needs. And so if you look at the matrix here, I got the axes on the vertical axis on the left side, and then on the horizontal axis I have the free mill, the product configurations. So we have basically 4 configurations that are commercial configuration that basically cost money, and then we have the free mill product I mentioned. You can actually download the demo today and get the free mill product. And this is really, as I mentioned, for tire kickers who don't know CAM, want to get into CAM, but they want to get their, they don't want to spend any money at that point, but want to learn a little bit of that, of CAM. And then students as well. A lot of students use this product. And then we have the standard configuration, which retails for $1,500. We're doing a sale right now, actually a month-long sale, which is selling for $9.99 US dollars. By the way, these prices are only for North America. We do have resellers in other parts of the world, and the pricing might be different. In Europe, for instance, all our resellers sell in euros, so because of customs and things like that. And taxes, local taxes, prices are different, so you need to check with the local resellers to get the correct pricing. So the standard product includes full 2.5-axis and 3-axis support. And then we have the expert product, which is typically used in the production of the jewelry industry. Includes 4-axis, not only index 4-axis, but also 4-axis continuous machining. And then our professional product, which is really used for mold and die, automotive, music, and a lot of the professional type of people who are really using our product on a day-to-day basis, they would prefer this this configuration. Retails for $5,000. It's a perpetual license. We don't have a subscription licensing yet. We're looking at it, but at this point, we can only offer a perpetual license, and that's the pricing on the professional configuration. What that includes, on top of all the other functionality that you get in the expert module, you also get the 3+2, which is basically indexed 5-axis machining, if you will. Some people call that index 5-axis. We also have advanced 3-axis machining, lots of different advanced toolpath methods that you can use in the 3-axis part that makes your job easier, optimizes your toolpath, gives you better toolpath finishes on your finished part. That is. And finally, we have the premium configuration, which is the entire ball wax. You get everything, including the kitchen sink there, and that includes 5-axis continuous machining as well. So if you're in the aerospace market, advanced woodworking, you need 5-axis continuous machining, blow mold machining, where you're cutting different, cutting out flashes from blow molds and things like that. That's the product you should be looking at. And we also have turn, art, nest. These are modules that can be added on top of the mill products that I just talked about. And you can get all the pricing information from our e-store. We just launched an e-store. If you go to our website, If you click on the eStore button or Buy Now button, you'll be able to see all the pricing. We're pretty transparent about our pricing, so it's all there. So go ahead and take a look. All right, Joe. And now let's jump on to the demo here.
Yeah.
Thanks,
All right.
Joe.
So the way, thanks, Joe. What we thought we'd do is just do a little bit of a, start off with a little bit of Onshape. And Uday and I are both working together. And I think the point I want to make here is not to give you an overview of Onshape. I think, like I said, there's other places that we can cover this in detail. But for those of you that are using it, there are certainly a couple things I think you should try if you haven't. And the first is just the fact that, keep in mind that this is a great scenario that, let's just say for the sake of argument that this is the part that I as the engineer am working on. I'm building a gearbox. And so I've done the design as the engineer, and now it's time for manufacturing. So a scenario is very common where I probably have someone else that's the expert in manufacturing. In this case, it's going to be Uday, but it could be someone else. You have several options, right? If you're using a typical CAD system, your option is hoping maybe they have the ability to read your CAD system, and then you could send them, you could zip it up and send them your, SLD, PRT, or whatever it happens to be. Or you can also zip up a step file or an IGES file, zip and email it to that person. Problem with that is
it's called throwing it over the wall.
Exactly. It's what we all do, right? Or we used to do. And this was probably almost one of the number one reasons we thought that life could be better. There's a lot better way than doing that. So for us, the idea is you can share with somebody. And so I can share with anybody that I want to work with me on this model. And I have complete control over the types of permissions that person has. Because remember, Onshape is free. So the interesting thing here is all I need to do is put an email address in at .com. And so, but as long as I know that person's email address, I can share with them. I can give them any permissions, and I could also take those permissions away. So as an example, I might share with someone for a limited amount of time and then remove those permissions, give them time to create some of the toolpaths. And I never worry about, do they have Onshape? Do they have the right computer? Do they have the right version? All that's just taken care of, none of those hassles. The other thing that's really interesting is that you'll notice that there's a big M up there. So Uday is actually, I've shared this model with Uday, and he's in the model as well. And this is the type of thing that we can do together because we don't have to create a copy of it. He's working and seeing the exact same thing I am. We're both in one, there's one source of truth. So the entire world can work on this one part. And a couple things we could do. If he makes a change, I see it. If I make a change, he sees it. We don't worry about it. There's a whole versioning tool that we can start putting in versions and create branches, and there's a ton of capability to give us some control over how we work together. However, one of the interesting things, I'm going to do one last thing and then turn it over to Uday, is if I click on Uday, Uday, if you want to rotate around or give me some, pick up face and just zoom in and out, this is just another built-in default functionality of Onshape. I'm not touching the screen now. This is us working together, and again, just in our product, I shared with Uday. I've given him a certain level of access to the model, and we can work together to collaborate on this design. So it really does simplify the idea of working as a group or working with more than one person. So I don't know anyone that does everything all by themselves. There's always something that you need to do to work with someone else in some ways. So I think that is what I wanted to show. Uday, Alex, why don't we make Uday the presenter, and I'll kind of field some of the questions as we go through this.
Thank you, Joe. And folks, as you're able to see, Joe and I are both working on the same part in Onshape here, and I have the part and Joe has shared it with me. So now let's take a look at how we can take this model that you've designed in Onshape into Visual CAD-CAM. So I go ahead and start up the Visual CAD-CAM application. And right under the Home tab, I'm going to go up to the Visual Import for Onshape, and I would select Import from Onshape. So when you click on Import from Onshape, this automatically displays your Onshape Document Manager. obviously you got to just sign in for the first time into connect your documents into through the document manager, and then you can go ahead and look for all of your files in here. So I have several different files, and you can pick the part that you'd like to program. So just select the part and then click the load button. So this automatically transfers your file into the Visual CAD/CAM desktop application from Onshape. So without having to go through any of the manual file transfer process, your part is already in here. And you can work within Visual CAD/CAM now to program your part. So we already got the part translated in just a few seconds in here, as you can see it. Now we are ready to program some toolpaths. So you can go up to the Visual CAM menu and you can select the module that you'd like to use for programming. So in this particular case, this part is ideal for our milling process. I have the mill module selected, and you'll notice that the milling interface appears over here on the left panel. It's automatically docked. You have the machining operations browser in here, which gives you access to your program, and then the simulate tab. And then the machining objects browser, which typically appears right below the machining operations browser, gives you access to defining your tools, machining regions, features for detecting hole features, and also knowledge bases. Now the typical workflow in here is work your way from left to right as you work through each of these groups under the program tab. So the first step, you want to determine if this part is going to be programmed on a 3, 4, or 5 axis CNC mill and the type of process you're going to be applying for it. So we'll go up to the machine setup under the program tab and select the type of machining process. So for this particular application, I'm going to pick 3 axis. 4 and 5 axis options are also available. So if you have a 5 axis machine and you'd like to machine parts from different orientations, you can do that. In the next step, you would want to select the pulse processor. This would be the CNC machine tool that you're going to be writing out the G-code for. Visual CAD/CAM includes post processors for over 225 plus different machine controllers, which covers a wide range of CNC machines that are out there.
And these are all free, by the way. Free post processors, yeah.
And these post processors can also be customized by editing them, so you can add, build new post processors. If your machine reads ISO G codes or standard G&M codes, we can develop a new post processor for it. So then specify your extension for the posted file. It could be NC, CNC, or whatever is the preferred extension. Once you establish that, you'll notice that the machining browser automatically displays all of the information. So the machine is defined as 3 axis. Your post is now established as Haas. In the next step, you would want to establish the orientation for machining. So typically when you design a part, you would probably be considering how it's going to be machined. So you want to make sure that the orientation looks right. If you need to reorient the part, you can use the controls under Orient Part to change the orientation. And then you're ready to define your stock geometry before you start creating some toolpaths. You can go up to stock, and there's a wide range of different options for defining stock. I'm going to go with the box stock in here. And this automatically determines the minimum stock extents that's required based on the geometry that you imported in here. So I'm going to round off these numbers. I'll use 80 millimeters by 90 millimeters for the length and the width, and the height I'm going to change this to 32 millimeters. Now once the stock is defined, you can preview the stock right on top of your model. The next step is to go ahead and align it, and we'll have the stock aligned, and we'll flush it to the bottom in a Z, so the bottom of the part is nice and flat. So we're going to flush it to the bottom, and we'll have it centered in X and Y so you don't leave a factory edge and you clear material from all the 4 sides. Now the next step is to establish your origin. So you can go to set wall coordinates. You can pick set your origin to the stock box, since in this case the stock is larger than the part. And I'm going to put the 0 face to the highest Z, which is the top face of the stock blank. And for the 0 position, I'm going to pick southwest. Now if you'd like to pick a center of a hole, or you can snap to any point, you can use these controls in here to do that. Now as notice here, the workflow, what we are working through is going from left to right as we work through each of these groups. The next step is to set your material type, depending on the material you're going to be using for milling this part. So I could pick aluminum 6-61, or whatever material you prefer to use. And then you can also display the texture of the material in here. And when you go to your Simulate tab, you can see the texture of the material is being applied to it. In the next step, you're now ready to program some toolpaths. As Joe pointed out earlier, Visual CAD/CAM offers you a wide range of toolpath methods. Under 2 axes, we have several methods starting with roughing, facing, pocketing, high-speed pocketing, profiling, V-carve roughing, engraving, chamfering, hole pocketing, thread milling, and remachining. The 3 axis offers you even a larger set of methods starting with roughing, re-roughing, clear flat machining, pre-finishing and finishing methods, remachining and pencil tracing, curve-based machining methods. And of course, we do have 4-axis methods for both indexed and continuous 4-axis and simultaneous 5-axis methods. And you have whole machining methods for 3-axis and 4-axis methods as well. Now for this particular part, I would like to start with first roughing it out. So I'm going to go up to 3-axis and we'll use roughing in levels. So it's called horizontal roughing. Now since this part has sculpted features on it, so I'm going to use 3-axis roughing. And I'm going to skip the process of selecting any containment areas, so the system will automatically determine the areas that needs to be roughed based on the stock and the part geometry. We'll select a tool in here. If you'd like to make edits to your tool, you just double click on it and you can establish the properties of your tool. You can specify the material and the feet and speeds. There's also a built-in feet and speeds calculator in here based on the stock and the tool material type. Visual Cam can give you recommendations on the feet and speeds. Now, once you've established the feet and speeds, you can then go into the feet and speeds tab and you'll notice that the feet and speeds are automatically loaded from the tool. And then the next step is to establish your clearance. This is your safety plane for your transfer motions. You can notice that when this tab is active, the clearance plane automatically is displayed on top of the part in your viewport. And then you can establish your cutting parameters in here, your tolerances, your start to leave. You can choose your cut pattern, cut direction, step overs. You can specify your cut levels, how fine you would like the cutter to step. Specify engage and retract in any button, and the system automatically determines your tool path based on the part and the stock geometry. So it is computing your roughing tool path based on the tool that you've selected, the parameters that you define, and once the tool path is computed, you'll notice that the tool path automatically previews on top of the part in your viewport. And what I'm running here is a multi-threading manager. If you have multiple operations, you can generate them simultaneously, and each operation can be processed on a separate thread. So the roughing operation has been generated, and it automatically appears under your operation tree under setup. You can click on toolpath visibility to preview the toolpath right there. You can see those nice arcs on your toolpaths. You can view the toolpath as you go through each Z level as well. So those are your roughing in levels toolpath. Now let's go ahead and run a verification in here. So let's switch to the Simulate tab. You select the operation and hit the play button, and there's your verification right there. Your cut material simulation. You can always pause it and then hit simulate to end to run through the simulation. So once you have it simulated in here, in the next step you may want to go back and finish some of those areas. I would like to clear the flat. So you can do a combination of 2 and 3 axis operations. Here I'm going to use a facing operation in here. Select the features. I can directly select the surface edges from the model, as you can notice it here. I'm not creating any additional geometries. I'm taking the face edges that were built as part of your design in the Onshape model in here, and those are the face edges. I'll still go with the same tool, the same set of feet and speeds and parameters, set my parameters for roughing, and then click on generate. And there's my 2-axis facing toolpath to clean up the top face of the model. And hit play to run the verification. So you can program these toolpaths in here. Now I want to go back and finish up these holes. I'm going to program a hole profiling operation, 2-axis hole profiling. Select my machining features right in here and grab a tool for it. We'll still go with the same tool, specify all the cutting parameters. I'm going to pick the depth of the 3D model in here by snapping to the top edge, and I'll pick the edge near the floor of the part, and there's my total depth. And I can specify all of the additional parameters in here. You can also choose your entry and exit and then pick generate. And there's your whole profiling operation. And go to simulate to run your verification right there. Now I would like to go back and clean up the flats in these areas in here, so we can use one of the advanced 3-axis methods called clear flats machining, where you can basically select just to mill certain areas in the model. I'm going to use a containment in the Z. I can pick where I want to contain it, as you can see right there. So I only want to cut these flats out, specify all your parameters, and then pick generate. In this process, it'll automatically go back and clean up these flats where you have the flats around the filleted edges in the model. So you can program using a combination of both 2 and 3-axis methods in here to efficiently program your part. So you get precise control on each of your toolpaths. There it is. Now I would like to go back and finish these exterior shapes and then also do a chamfer on it. Now, since I would like to restrict the toolpath to a specific area, I'm going to use a boundary in here, so you can use some of the drawing tools that are available to you in Visual CAD, and I'm just going to throw in a larger boundary in here. And now I'll go back and program a 3-axis finishing toolpath. So I'm going to use finishing in levels, which is known as horizontal finishing, and I would like to contain it between these two boundaries in here. So you can use some of these drawing tools to quickly create these boundaries. You can specify a tool for it, specify your cutting parameters, you can control your cut levels, you can also do an optimized machining, and then pick generate. So in this process, it's going to do a finishing in levels to finish all of the features on the exterior in here using a ball mill or radius tool. So you could be programming multiple operations at the same time. So while the horizontal finishing is being programmed, I could go back and add a chamfer operation in here to select my features for chamfering. So I'm going to pick this edge right over in here and pick the geometry for chamfering. I'm going to grab this edge and go grab a tool for it. We'll pick a 45-degree chamfer, specify the parameters for cutting, and I'm going to choose to determine the side to cut based off the 3D model. So it knows that the chamfer needs to go on the inside and not cut the outside. You can specify your parameters for entry and exit and then pick generate. And there's your chamfer toolpath. We just got done with the horizontal finishing also. Look at the nice toolpath right there. Finishing in levels with an optimized machining. And we got the chamfer in here on the inside. So let's go ahead and run a verification for those. And hit the simulate button, and there it is. It's finishing it up. If you'd like to speed up the simulation, you can use the controls right in here to have it go faster or slower. You can also pause it and then pick simulate to end to run through the simulation. And there's your chamfer. So you don't necessarily have to have the chamfer model on the part. If you just want to break the edge, you can create a chamfer toolpath. Now finally, I would like to mill this fillet using a fillet mill tool. So I'm going to use a 2-axis and a profiling operation in here. And I'll go ahead and grab the same set of edges. I'm going to just grab the edge right here at the fillet, at the base edge of the fillet. And you can basically select multiple face edges. Now once you have this selected in here, I'm going to go to my tool selector, and I have a fillet mill in here. The fillet radius is 1 millimeter, so I have a corner radius of 1 millimeter set for the fillet tool. I have the tool selected, specify the cutting parameters, and again I'm going to use determine using 3D model, so it automatically knows which side to profile the fillet, and then you can specify your entry and exit parameters and then pick generate. And there's your filleting toolpath right there. If you'd like to make any changes or edits to the parameters, you can always go back and edit it and make changes in here to your entry and exit parameters, and then regenerate the toolpath. And there it is. So let's go ahead and run a verification. Hit the play button. There it is. Your part is now...
Slow it down with A. Can you slow it down? I want to see the fillet.
Sure, I can do that. There it is. Was it better, Joe?
Yeah.
Okay. So once you got all your toolpaths programmed in here, you could go back and take a look at your estimated machining time. It gives you all the information for each operation and then subtotal right there. And you can also generate a very nice setup information sheet. This can be done by going to shop documentation. You specify your file name, you pick a template, and then hit save. So this basically creates a setup information sheet, gives you information about your stock, your tools being used, your operations, and also the parameters. There it is. Gives you total 7 operations using a total of 4 tools, total machining time. So this information could be very handy for the machinist in the shop floor who's looking to get things set up for milling this part. And then finally, you'd want to go back and post-process this out to your machine. So right-click on your setup or the machining job and click on Post. Specify your file name and extension right here, and then click on Post. And there's your posted NC file. This is now ready to be transferred out to your CNC machine. You can see that the tool changes are being called. There's your tool number 1. You can look for the next tool number in here. So there it is. So this basically gives you a workflow of how you can take your parts from Onshape into Visual CAD/CAM to program it. Now I do want to bring up one other part here where we have capabilities to program several different types of toolpaths. Here we have multiple setups. The part is being programmed in several different orientations. You have some roughing and finishing toolpaths being programmed, from the top orientation, the default orientation. You can go back and program it from different views, different orientations. So if you have a machine tool, it's a 5-axis machine, and you need to index it and reorient it and program it, you could always program it from different orientations in here. You can always go back and run a verification of it. There it is. And you can, of course, run a, simulate, change the speed of your simulation. Joe, would you like to add anything to it?
I think we're good. I think maybe we can pause for questions now. Joe?
Yeah, I've been typing. Sorry, guys. I turned off my mic because I didn't want you to hear my keyboard, but I've been trying to answer all the questions. So let's see. One question was about storing the information in the Onshape model. So it's really probably a question, no good answer for it. But I mean, the question is, does this get stored, what or does anything get stored in the Onshape model document?
The CAM data, the question?
Yeah.
No. The short answer is no. Basically, our product is a desktop product. So once you bring in the model, you program the part in the desktop product, and then you can save it as a file, as one of our native file formats, and that's where the storage will take place. We do not, go back and store anything back in the Onshape model. Not yet anyway. So
yeah, not yet automatically. Now, I was going to say, it's all. I'd recommend doing this, and this is how I use it. You can just add it, your document, any document, you can put whatever you want in it. So you could put your report. Actually, the HTML report was very interesting. That we should be actually looking at doing that. But you could put your G-code file in the document. You can actually put your visual cam file in the document. So, and that will honor. It's a little manual at this point, but you can use the good thing about doing that is our versioning then will also, our version graph and the branching and merging also will honor all those. So you can do basically a management with all the data. And we should look at doing a little bit more integration on that as time goes on, Joe.
Yes, yeah, we will, definitely.
There is a question on, where is it? Sorry, I need to expand it. IRB cam and visual cam.
Mm-hmm.
So programming robots.
Yes, we can do that. Uday, you want to take that question?
Sure. So once you program your toolpaths in Visual Cam, you can export the toolpaths that you program to app CLS from Visual Cam, and then you can take the app output from Visual Cam directly into IRB Cam to program your robotic arm. So this could be 6 or 7 axis robotic arm. So you can generate full 5-axis toolpaths in Visual Cam, and then you just have to export the model out as STL and feed that into as your data for IRB Cam, and you can just take the toolpaths out. So Visual Cam can produce the toolpaths that you're looking for to be able to program in your robotic arm, and that can then be transferred into IRB Cam for generating your kinematics for your robotic arm.
Cool. I did not know that. Is there an upgrade path for version 6? Let me see what we got here. Yeah, so Visual Mill version 6. What version are we at right now compared to version 6?
We're version 2016. There's quite a few versions before them. Yeah, definitely there is an upgrade path. It's not like you're going to buy a new product. I think you should give us a call or drop us an email, and we can figure something out. So
we have it. You'll see it, and we can share that info with you later, Joe.
Okay.
We didn't go to the App Store. I think that might be a good idea to go to the App Store and. Uday, do you want to show them how you actually get Visual Cam and start using it with Onshape?
Absolutely. So I'm going to go back into the document here in Onshape. So now if you go down to the bottom, you go to the tab right there, you can click on Go to App Store. And then I have the App Store tab right in here. In the search box, just type in MecSoft, and it'll take you directly to Visual Import for Onshape. And you click on Go to Download and Installation Site, and this brings up the MecSoft partner page right there. And here are your free steps. So once you have Visual CAD CAM installed, you can choose between 64 and 32-bit download. The next step is to download the Visual Import for Onshape. And then when you launch the application, you'll see the Visual Import for Onshape plugin right in under the Home tab. Then you can start camming right from Visual CAD CAM. So that's how simple it is.
Yeah, let me walk you through the steps a little bit slowly here. Uday's expert CAM programmer, so he tends to think everybody's on the same level. So, but I'm a little bit slow, so I'm going to walk you through this. If you go back to step 1 there, Uday. So the first thing you want to do is once you get to the App Store and you come to our page, download Visual CAD CAM installer and install it on your machine if you haven't installed it already. So this is our latest version of the Visual CAD CAM product, of the 2016 product, and depending on the machine that you have, the desktop machine, you either do the 64-bit or the 32-bit. And obviously ours is a Windows-only desktop product, so you need to have a Windows machine to run this. So once you have that installed, then you go to step 2. Uday, if you want to click on that, please. Yeah, here you download this Visual Import for Onshape plugin. What this is a separate installer, and you would install it, and it'll automatically install the plugin to run inside of the Visual CAD CAM, which you had previously installed. And then once you do both of these steps, then you go to step 3, and you basically launch the Visual CAD CAM product. That will be either in your in the taskbar, or in the run, from the run command you can run it. And once you come up, you'll see that ribbon bar up there like it's shown in the picture. And then you go to the plugins tab and then click on the menu. One of the menu items will be Visual Import for Onshape. And then once you click on that, and then you can load the Onshape models from the Onshape account, your Onshape account. Obviously, you need to have an Onshape account and have some models created in there for you to be able to load those models. So.
I think we're doing part studios only too, right? We're not doing assemblies. Right. Yeah. So if you have an assembly that you want to machine, it's very simple to put. You can make a copy and put those into a parts studio. Do we do multi-body? That's the other question. If you have
we do multi-body now. Yeah.
Yeah. Okay. So you just need to get your geometry into a parts studio.
Thanks, Uday.
Thank you, Joe.
So given the time, guys, we went, I guess I talked a lot more than I usually do. We're at the end. So I think I would recommend if anybody has a question, why don't you make sure this is going to be the last chance. I don't want to go, I try to be very conscious of everybody's time. So type a question now or forever hold your peace, I guess is the way to put it. There was a question about when we're going to, when both of our products are going to support Hindi. So I will say we will be supporting that as soon as the demand is high on that, but it's coming. We're starting, by the way, on just so you know, on Onshape's end of things, on multi-languages, we are rapidly approaching having that capability. We've got a lot of infrastructure. There's a bunch of languages that are already working, and we're going to start rolling that out. I don't know what the dates are, but I can tell you that you're going to start to see multi-languages introduced at a very rapid pace from Onshape. There's a question on MecSoft on what CAD systems you support.
Uday, you want to show the drop down on the different file formats that we can pull in?
Sure, I can do that. Thank you. So I hope everybody is still able to see my screen in here. So if you go up to the open dialog, and you'll notice that Visual CAD CAM supports a wide range of formats. So you can bring in your native Visual CAM and Visual Mill parts from older versions, turn parts, 3D Studio files, Adobe Illustrator, AMF files, AutoCAD, DXF, DWG, IGES files, Lightwave, OBJ, Parasolids, point cloud files, raw triangle files, native Rhino 3DM files, SAT, SketchUp files, SLC, STEP, STL, U3D, and VRML file formats.
And then you add all the formats that Onshape supports, which is a whole handful that aren't included here. Combine these two products and you have I don't know if we're missing anything. I think it's pretty much every format I've ever heard of almost. So there's direct mechanical CAD formats from within Onshape too. So consider that. Hey, there's a question on subscription. So the question was, do you intend to support a subscription-based pricing?
Yes, the short answer is yes. We're actually looking into it right now, and we have, with the latest release of the 2016 product, we went to software licensing. If those of you know our products, we used to ship with a hardware key or a dongle. In the 2016 January of this year, we released 2016 with software licensing. And now that has opened up the possibilities for us to be able to do, subscription licensing. And we are building the infrastructure right now. At some point, we'll be rolling it out. We're doing it on a limited basis for some of the higher-end products like the Professional, or the Premium, which we can manually handle those subscriptions right now. So if you're interested, give us a call, and we can work with you.
There's a question on integrated app, and I guess probably that's, do you intend to support an integrated app? I think you can decide to answer that. Joe, I don't know if there is a good answer for that, but.
Yeah, we're definitely looking into that. Obviously, it's a very natural thing for us to be looking at it. Things are evolving in terms of cloud technology. And obviously, Onshape is completely cloud-based. And since we are working very closely with them, we are definitely looking at doing something on the cloud. I don't have any time frames or anything like that, but rest assured that we are doing our due diligence there and making sure that we're able to support. There are a lot of pieces in our product that needs to actually run on the cloud before we're actually able to create a product of the functionality that you just saw. So yeah, there's a lot of work going on. Let me put it that way.
Okay, I think that's it, guys. We've hit 9 o'clock or
All right.
1 o'clock.
Thank you very much, everybody.
12 o'clock. Yeah. Thanks, guys.
Thanks for attending.
Go get the product and try it. You can start cutting parts today, right now.
Thanks for watching the webinar.